this unit, and really the last two, I would say. Um, I don't even know why they break them up into different units, but hey, look at what we're starting off with, the sequences. Now, these are arithmetic sequences. You saw this in the first semester. You'll see geometric sequences shortly, but for right now, it's arithmetic. Well, like a geometric sequence, an arithmetic sequence is a group of numbers. But unlike a geometric sequence, where those numbers have a common ratio, what relationship do the numbers in an arithmetic sequence have? A common difference, which means that to get from one number to the next, instead of multiplying or dividing, you're adding or subtracting. So like if I look at this first one, clearly we're adding and we're adding 2. And if I were to keep them going, 10, 12, 14, yada, yada, yada. What do they want me to find next? Huh? Yeah, the 42nd term in the sequence. Right now I have 7 so far. They want me to find the 42nd. Which means if I were to continue doing what I'm doing now, which is finding terms recursively, just going from one to the next, well, it's going to take me about 35 more times. I really don't feel like doing that. Okay. Now, I can go ahead and write the recursive definition already. A sub 1 is 2. The first number is 2. And then every number thereafter is the number that came before it plus 2. That 2 is the common difference. I'd rather find it explicitly. So let's see if we can write our own explicit definition. And this goes back to the first 9 weeks. Any number. Here, how about this? There's a word that can be used to describe the explicit definition of an arithmetic sequence. What's that word? What word can be used to describe what I'm about to write? No. Well, common difference is what an arithmetic sequence has to go from one to the next. But what I'm about to write, what's coming after this equal sign, that expression that I'm about to write there, is a word that I can use to describe it. It starts with an L and ends with linear. Yeah, linear. Whereas a geometric sequence, which are the ones that we just most recently studied, what word can be used to describe that explicit definition? Exponential. I know the kids that were with me first semester did this. Everybody should have done this. I'm asking you to go in the Wayback Machine, but here, I guess I'll just. Does anybody remember how to do the explicit definition for arithmetic? You guys remember what the formula is? I don't see it here on the page. You gotta start off with a sub 1. What's a sub 1 here? It is 2. Then after that, you put the common difference, which is 2 again, we would write plus 2. Minus 1. Now, what is done a lot more commonly is that gets simplified. You don't see it as much with the geometrics, but these do. Like if I wanted to simplify this, what can I do? What can I do if I wanted to simplify that? Distribute and distribute and combine like terms. So watch. A sub n is equal to 2 plus. Now you don't have to do this. If you wanted to just go ahead and plug in 42 already, you could. Doesn't necessarily have to. I just like to. So plus 2n minus 2. Here the like terms cancel. 2 minus 2. So all I'm left with is a sub n is equal to 2n. If you wanted to check and see if it worked, plug in any of the numbers that you know. Like I just found out 14 was which number in the sequence. Where was it located in the sequence, the 14? It's the seventh number. If I plug in a 7 param, what's 2 times 7? Yeah, it is 14. It works out. So now that I have my, remember, nothing says you had to simplify it, but I like simplifying. Let's go looking now for the 42nd number. The 42nd number would be 2 times 42, which is equal to 84. And even with all that explanation, if you would have attempted to find it recursively by going one by one by one, we probably still would have found it around the same time. Miriam would have taken longer because she's distracted. Or, sorry, I said Miriam, Martha. No calculator. No phone. You have to get a calculator like the cavemen did. Why don't you guys do the next one? Maybe do the next one. We'll do the definitions together. Just give me the 33rd number. That's what I want you to find. And then I'll assume that if you got the 33rd number correct, it's because you have the explicit definition. Jason, you got it already? No. Go, Caleb, go. Go, Caleb, go. And you got it? What'd you get? For the 33rd number? Maybe I did it wrong. What did you get, Marquise? I think that's right. So, the explicit definition is the original amount, which is 5. The common difference here is plus 5, then minus 1. See it like that. If this were like a Khan Academy problem, it should be fine with you entering it like that also. I like to simplify. So I'm going to say 5 plus 3m minus 3. And did you add maybe instead of subtract? So that's 3m plus 2. So now I can just say that the 33rd number times 33 plus 2, which is 99 plus 2, which is 1. Let's see if we can do the third one by yourselves. This is slightly different, not much different, but slightly different than the first two. Yes. Yes. Sorry. Yes. Who can multitask and like while you're working, tell me what's different between this one and the previous two?
That one's subtraction.
Say it better. Say it smarter.
That equation.
No. You can say it better. Brandon, you want to say it better? What? Now. Bri. Yeah, you do. Continue your calculator. Kiara. Marquise, you got the answer? Okay. Well, I think, yeah, I did it in my head. That's the same thing I got. But answer my question first. What's different about number 3 than the previous two? Oh, beautiful. The words is just, that's exactly what I wanted. You're perfect. Common difference is negative. That's the only difference. Common difference is negative. So when we use the formula for you know what? Maybe I should write this down so that you can write. I think I said it, but I didn't write it down. So if you guys want to write this down again, this is the explicit formula for arithmetic sequences. So I would write that any number is the first number, which is 10. In this case, since the common difference is negative, I'm going to write -3 where the common difference goes. That's what Caleb did. And then the n minus 1. So not that you have to simplify, but I like to try to get the most out of everything. Why do less steps when you can do more steps? That's what I always say. -3n plus 3, so we get -3n plus 13. So I just plug in a 29 for n. A sub 29 is equal to -3 times 29 plus 13. And I believe, as Marquis said, that's -74, you said? Any questions there? Read, question? No? Right. Next page. Josh was making a sequence pattern out of triangle blocks. If Josh continued this pattern, how many triangles will he need to make the 20th step of this pattern? So let's just count how many triangles there are. How many triangles are there on the first one? Then how many triangles here? 3. No. How many little triangles? I'm counting 4. And then on this one? I'm counting 7, yeah. And then? 4, yeah. So can we see what the pattern is already? Is this arithmetic, geometric, or none of the above? Yes, the arithmetic. So in order to make the 20th, I could keep on going and add 20 more times. Or let's just jump to the explicit definition. The first number was 1, the common difference is 3, and 10 minus 1. Just to show you that it works even if you don't simplify, let's just do this one here for fun without simplifying. A sub 20 is equal to 1 plus 3 times 20 minus 1. 20 minus 1 is 19. 19 times 3 is 57. 57 plus 1 is 58. You can double check my mental math. Okay. Consider the sequence, blah, blah, blah. They go through this whole explanation. Let's just focus on here the question, which says create a sequence based on 4x minus 1. So, table. So for x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I plug in a 1 for x, 4 times 1 is 4 times 1 is 4. And then minus 1 is 3. 4 times 2 is 8 minus 1 is 8 minus 1 is 7. 4 times 3 is 12, minus 1 is 11. The whole purpose of this exercise, I believe, is that once you get a few numbers going, what do you see is happening? Once we get a few numbers written down, what do we see that's happening? Very good. The common difference is 4. And then that gets you to say, okay, well, geez, let's look at this formula. And where can I find the common difference? Where do you see that same 4 inside the formula? Come on, I'm taking you on the path. I'm holding your hand. Don't let go. Nakai started us off saying, hey, the common difference is 4. I said, yes, I agree. So then I brought your attention back to the explicit definition. And then I said, hey, where do you see that 4 there? No, where do you see the 4? On the dot? No. I mean, the layperson would say, oh, hey, Mr. Maria, I see it. It's right in front of the X. And then I would say, well, hey, guys, well, since you've already told me today that arithmetic sequences are linear, back when we did linear functions, the second month of the year that we did linear functions, y equals mx plus b, what did we call that number that was in front of the x? The slope, yeah. So what's the common difference? It's the slope. And then we can, I mean, if you want to keep on plugging in, you can, or you can just keep on going up by 4. Yada, yada, yada. You can go as far as more. And then the next one asks you to describe the domain and the range. I'm not sure what they meant by this. Describe the domain and range of a function that might describe the sequence of. Yeah, I'm not too worried about this part, but what I would tell you is whether you call them x's or n's, that's the domain. The domain is what you plug in, is all those numbers. 1, 2, 3, 4, 5, whatever you plug in, that's the domain. And then this part right here would be the range. So like, I mean, if they are talking about this particular sequence, whatever it might be there, looks like the common difference is -3. Are these numbers part of the domain or the range? Yeah, those are part of the range. Those numbers are part of the range. What would be the domain there? Well, 1, 2, 3, 4, because those are the first number, second number, third number, fourth number. Strangely enough, the next question says, what's the common difference? It's the exact same sequence. We just finished saying, what's the common difference there? Yeah, common difference there. The numbers are going down by 3. Write a recurrence relation. For all intents and purposes, assume that that's the same thing as saying a recursive definition. I'm gonna bypass this because we did this on the first page. We've done this already. Let's just highlight the key things here. What's the common difference on number 8? Caleb, this is the new you that's reinvented, and you're gonna tackle this unit. No, it's 2. Here it's 2. We're going up by 2. A sub n is going up by 2. That's the common difference. And what's the first amount? 5. Yeah. So feel free to do that one on your own. I would like to finish this in 2 days if possible, but if it takes 3, fine. But I don't think this should take 4 days. Everybody else is taking 4 days on this. I don't think this should take 4 days. Write a recurrence relation and an explicit definition for the following graph. All right, it is neat because look, we just finished making an analogy of a common difference being the same as. We just made a comparison. It's a slope on an arithmetic sequence. The common difference is a slope. Well, here's a graph. Like that's what we've used the word slope before, is to describe graphs. So let's see if we can do this now. Maybe actually, let's just leave it here. Let's leave it. I was gonna make it as a table, but we can leave it as a graph. So just understand that this is the n-axis now, and this got cut off, but this should be the what do they want to call it? Then I'll tell you. All right, but then let's call this a sub n. That's the a sub axis. So this here would be 1, 1, 2, 4, 3, 7, 4, 10, 5, 13, and 6, 6. And remember, we just used the words domain and range to describe, like the n would be the domain, and the a sub n would be the range. So here, what's the first output there? Like when n is 1, we also got a 1, sure, and a sub n is equal to a sub n minus 1, and what appears to be the common difference / slope? It's 3, yeah, remember slope, right, when we're running, we're going up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. So the common difference here is +3. As an explicit definition, this would be the first amount, which is 1 plus 3 times n minus 1. If you leave it like that, it's fine. If you wanted to simplify, you can do that also. You don't have to know. 1 plus 3n minus 3, which is 3n minus 2. Who remembers what that meant from linear functions? We did linear functions. What that number represented? The one that's in the green box. The y-intercept. And if I were to connect these dots and make a line, well, guess where I would cross the y-axis? It's also in the green box. Is that Kiara? Oh, Martha. I was about to say. Okay, now we move on to geometric sequences, which I don't know if they're easier, but they should at least be fresher because we just went over these. What's the difference, no pun intended, between geometric sequences and arithmetic sequences? Instead of a common difference, now we have a common ratio. To go from one number to the next, we're multiplying or dividing. What's the common ratio here on the first one? It is times 2. So 48, 96, 192, blah, blah, blah. But do you want to keep on multiplying 17 more times or not? Well, let's see. Recursively, a sub 1 here is 3, and a sub n is the number that came before it, but now it's going to be times. For the second time today, somebody not named Ann, tell me what word can be used to describe the explicit definition of a geometric sequence? Exponential. Good. So now that n is going to be up on the exponent. A sub n. It's still equal to a sub 1, which is 3. And but now it would be times that common ratio, which is 2. You can use a dot, or you can use, I like 3 times 2 to the power of n minus 1. This actually could be simplified. It's just you don't see it done as often. So I'm not going to do it either. Instead of trying to simplify it, let's keep things simple. A sub 24 is equal to 3 times 2 to the 24 minus 1. Which is equal to 3 times 2 to the 23rd power. And I mean, I don't know, hopefully it fits in the calculator. 3 times 2 power 3. Yeah, it does. I'm getting 251, 658. Fax machine. Any questions? Let me know if I'm going too fast, but technically this has all been reviewed so far. We actually haven't covered anything new today. I really don't think, like, from what I've seen, there's not too much that's new in this unit. So. Here, you do the next one. Tell me what is the 16th number in this geometric sequence if I were to continue. Go, Shobi, go. Go, Shobi, go. G, O, Shobi. Go, Shobi, go. S, H, E, O, B, Y. Shobi, Shobi. Yay, Shobi. Boo, Caleb. Boo. Nakai, did you ask Caleb how he got hurt? You want to know how Caleb got hurt? Hurts, yeah, he's on crutches. Drinking water on the bench. No, I'm just kidding. It was like it's the next worst thing after that. On a jump ball. He got to enjoy the game for like half a second. Anybody got the answer? What'd you get, Caleb? Oh, so you don't have one. Yeah, Sam. That's not what I'm getting. I could be wrong, but because I haven't worked it on paper, but I think I'm right. What did you get, Ann? Yeah, that's what I got. I always check with Ann. If Ann says I'm right, then a few more. All right, here we go. The recursive is just to say that you just state what the first number is, which is 2, and and every number thereafter is the number that came before it times the common ratio, which is -3. The explicit definition would be that first amount, 2 times the common ratio to the power of n minus 1. Unlike the other one where I actually took some time to simplify, it's not done as often. You have to know your properties of exponents. You know, you're not really saving yourself much, so you might as well just substitute. So 2 times -3 to the 50. That's what you would put into the calculator. And as Ann said, that is -28,697,814. Got that, Shobi? If you have any questions, say something, and I'm moving on. All right, create a sequence based on. I'm gonna skip 12. We just finished doing that. Like that's just plugging in 1, plugging in 2, plugging in 3. Does anybody really want me to do number 12? It's just like all I'm gonna do is write a table here where I plug in. Is that even the same one? No, it's not. But that's all I was gonna do is for the top one. I would even tell you, let's actually skip down to 14. Like we just covered geometric sequences, but I think this is kind of neat. What's the word that we use to describe geometric sequences again? Okay, and remember now 2 units ago, so not this last test, but the test before it, where we were graphing exponential functions. Remember what they look like? And we had like the asymptote and stuff. You remember that? Well, look, here they graphed for me what they're saying is geometric. And take a look at what it looks like. Now, I don't know if I got the asymptote part right because I haven't written the function yet, but see how it looks exponential? Let's see what some of the points are. 1, 3, 2, 6, 3, 12, 4, 24. So the recursive definition is 3, and every number that comes after is the number that came before it times 2. So the explicit definition would be the first number, which is 3 times 2 to the n minus 1. And they're not asking us to find anything out there. If you remember anything from when we did exponentials, can you tell me where the asymptote would be? Yeah, it should be 0. Should be 0. So it'll probably keep on going down here, and then it would like cross. Because when I plug in a 0, 2 to the -1, so it should be crossing the y-axis at 1.5. So if I were to keep on going, it's gonna cross like around here, but even though it's gonna keep on going, the only thing it just won't get below is 0. Who remembers why? Like, meaning like he said 0. I just asked where the asymptote is, and he just told me the asymptote is at y equals 0. But I'm curious as to if he just guessed. Very good. K. Remember the y asymptote was always at k? Okay. Very good. Impressive. I'm sleepy. All right, so let's start again on 15. Given that a sequence is arithmetic and a sub 1 is 5 and the common difference is 4, find a sub 37. All right, so we've kind of done this already. I'm gonna go straight into it. Let's not even waste time simplifying. What comes first on an arithmetic sequence? If I'm gonna look for a 37th number, I want the explicit definition. What's gonna come first? The first number, and really that's the same thing for geometric. Like the whole purpose of this unit is to compare different sequences. So like if we're comparing and contrasting, we're gonna write the first number here that tells us it's 5. The difference is, no pun intended, that with arithmetic, it's a common difference. We're not multiplying, we're adding or subtracting. If my common difference is positive 4, I'm gonna write plus 4. Then if we continue to compare and contrast, they both have an n minus 1. The only thing is on geometrics, the n minus 1 is an exponent. Here it's just multiplication. And my n is not going to be n here. I'm just plugging in already. It's going to be 37. That's what I want to be. So that's going to be 5 plus 4 times 36. 5 plus 4 times 36. I'm getting 149. See if you can do number 16. I haven't done it already. Marquise, you did it already. Ooh, actually, no, I take it back. We'll do it together. You won't get this one. Maybe some of you would, not enough of you would. This is different. Because here, they don't want me to find a number way off in the distance. They want me to find a sub 1, but I can use the same formula. Instead of writing a sub 52, because they give me a sub 52, I'm going to first write 161. That's what is the 52nd number. That's equal to a sub 1. I'm just going to call this a for right now, just to make it easier to solve for. But the point is, instead of plugging in the first number, I don't know what the first number is, so I'm just going to call that a. What's the common difference? What's the common difference on 16? Yeah, so plus 3. And instead of writing n minus 1, what is that 161? That 161 is what number in the sequence? So then you're going to write 52 minus 1. And I'll just use your solving skills. That's 3 times 51, which I know is 153. So minus 153. And then, so what's the, what was that first amount? It was 8. Any questions so far? Ingrid? Okay, given that a sequence is geometric and the first term is 1536 and the common ratio is 1/2, find the 7th term. So let's just find the 7th term. The 7th term is the first one times the common ratio, which is 1/2 to the power of n minus 1, which is 7 minus 1. So that's 1536 times 1/2 to the 6th power. Since I'm not afraid of fractions, I'll go ahead and show you that 2 to the 6th is 1/64. So the same thing as saying 1536 divided by 64. For all you basketball fans, now with March coming up, even though fine they've changed the rules lately, like the March Madness is supposed to be of how many teams? So yeah, it's supposed to be 64. Now it's 68 because they have the play-in game, but traditionally it's a 64-team tournament. How many teams play at a time? Yeah, basketball is 2 teams at a time, right? How many rounds are there? So assuming you're one of the teams and you're always playing against 2 teams, how many rounds are there? If it's a 64-team tournament, how many times could you play against another team to make it all the way to the end? 6 rounds. It's 3 weekends, 2 games each. Play the 64, the 32, Sweet 16, Elite 8, Final 4, Championship game, 6 games. You're a Half-Life. Sounds better. Yes. Yeah. Every game, every time, half the team wins. Half of the teams win every game. If you have 2 teams playing, half of those teams win. So I'm getting 24. The second number will be 24. I got my 10 minutes. This might take a third day. We might not be able to use the. Let's see. All right. Given that a sequence of geometric, they give us the 10th number. So I'm not going to write a sub 10. I'm going to write 98 before 15. They want us to find A1, so I gotta let that be my variable. That's what I'm looking for. Times the common ratio to the n minus 1. But here they tell us that the n is 10. So 98 for 15 equals A times 3 to the 9th. 3 to the 9th. It's gonna be a big number. That's not too big. 98 for 15 is equal to 19,683 A divided by 19,683 divided by 19,683. Oh, I forgot a 1 here. So 98. 5. You're 5. 19,683. Nope. And he'll beat you on a jump ball. And he'll beat you on a jump ball. It's because he jumped over the guy's head and then on the way down he just lost his balance. And he won the war. Okay, some word problems. The value of an ounce of silver is about $16, and over the last several years, silver has increased in value about 7%. How much? Also, look, this is like from the test that we just took. If a value is increasing by a percent, is that geometric or is it arithmetic? It is going to be geometric. So here we go. Some final amount is equal to what's the original amount? Yeah, because they want to know 20 years from now. I was looking to see if they wanted us to go back in time or if they want us to go forward. It's 20 years from now. So 16 times, what's the common ratio going to be? Let's see, now that we're used to this, instead of having to use the entire formula, if it's going up 7%, 1.07. The power of, it's a good question. Should we use 20 or should we use 19? Is it going to be n minus 1? Right now, in the present time, how much time has passed? If we're going to say, we're going to count 20 years from now, starting now, how much time has passed? 0. So if that value of 16 was after the first year, then yeah, then you would put 20 minus 1, and not in this case, you got to put 20. So 16 times 1.07, power 20. There's money, even though we stressed this for the last test, it didn't work out too well. Should go to the hundreds. Technically, you're supposed to round up, and I took either one. It should be somewhere around $61.92. They don't tell us what around here right now. So if you put 61.91, that's fine. 61.92, that's fine also. A person having a graduation party noticed that only five people were there after the. Ooh, okay, I like this one. After the first hour, but grew in size by 61% every hour. If the size of the party grew this way for 6 hours, how many people will be on the party on the 6th hour? I like it. Is this going to be geometric or arithmetic?
Geometric.
Still geometric because we're going up by a percent. It's not like they're saying that if they would have said, every hour there's 20 more people, or it's an actual, like you're going up by like a common amount of people, then it's arithmetic. But if it's a percentage, it's always geometric. So the amount here is equal to the original, which is 5. Hopefully we know by now the common ratio, if it's going up, if it's growing by a percent, it's just 1 plus that percent.
6 minus 1.
Good. Why 6 minus 1?
Because it's twice the value of the first hour.
Yeah, because that number of 5 that we're starting with was after the first hour. So when they count here on the 6th hour, it's really only 5 hours after that original measurement was taken of 5 people. Now, if we're counting people, what do we round to? Yeah, and it will be down to the nearest whole number. So I'm getting 54.08. So that's going to be around 54 people. How about if we would have gotten 54.999999999? Yeah, you always round down. Unless you want to invite very short people to your. No, well, yeah, and they can also twist an ankle and jump off. They still deserve to be counted as an entire person. Jessica's creating a drawing on her paper called the binary tree. If Jessica continues drawing more branches, how many new branches will she need by the 12th step? Well, let's see. Oh, wow. If Jessica continues to drawing more and more branches, how many new branches will she need to add on the 12th step? So we're just talking about branches, so they all have the original branch, and then so I would say then that this is 0, then this is 2 because there's 2 branches, then this is 6.
That's
Why 4 though? Because I'm counting. Oh, because only the new branches, is that what it is? Oh, you can't count the ones that were there before?
no, sir.
Got it. But then this wouldn't be 0, then this would be 1. Based on what you're saying, because then this is 1, then this one has 2 new ones, then this one has 4 new ones, then this one has 8, so it's like that, 16. So is this geometric or is this it is geometric. And on the 12th step, let's just find the a sub 12 is 1 times 2 to the 12 minus 1. And 2 to the 11th is that 20, 2000 what? 2048. We'll call it a day there. Remind me that tomorrow then we'll take it up here where we're identifying different. If we can finish tomorrow, great, but we probably won't. So don't expect to have the laptops this week.